All right, welcome to another supercharged episode of the High Voltage Live Show. I'm your host, Willie Snyder, coming to you live from the Mile High City in Denver, Colorado, joined by my awesome co-host, Mr. King James Stallcup, over there in Hook 'em Horns Country, Big Sky Country, Texas, giving old Hook 'em Horns from the Mile High City. And we really appreciate you getting everything put together. And of course, we're going to sport up your link up in here, and everyone needs to jump up on in there and go check out the Stall Cup Electrical Education, the best online education out there. We dare anyone to compare. You have anything you think's better, please feel free to compare. They've tried. They have not succeeded. I mean, I do warn James that he kind of has to get himself ready, like just in case, like he has to maybe have like some kind of like what maybe I need to make something better, but I don't know, man. I don't know that you can improve that much on how good quality your illustrations are, the way you have the code loops and everything. And I'm waiting to hear word. We might have another Colorado journeyman buddy of mine that has actually been on this show. Do you remember when Bridget came on here?
Yeah.
When Bridget, so he came on. His name's Brandon. So shout out to Brandon if you got it, bro. I didn't get a text, so I'm crossing my fingers that he got it. But there's been a lot of people taking tests. One of our other guys just went and took their NISAT 2 and failed. So that was the second time he failed. So it's really rough. These tests are pretty tough, and that's why I created the Nat King Code brand, and everything about Nat King Code was to try to help people have like free study stuff where they could just go study at their own leisure and just make it fun. And at the same time, kind of see, what a bunch of the different code guys are saying about it. And I really appreciate all the comments that I've had on all my posts and everything. It means a lot when you guys come in. We had that Courier come in. He's a really cool dude. I think it's Joe Courier. He came in. He's a really cool guy. I think he's an instructor somewhere southwest, I want to say, or southeast. But it's really cool to have those guys come in and comment and give us their take on stuff. And I really appreciate it. It means a lot to me. And, like I say, it's always just trying to put together good good content. And when I saw the meme this week, I was like, this has to go with our show, man. I mean, this has to be like our own meme that's for our show, man.
Well, let's roll it.
All right.
Well, what would that be in his mouth?
That's funny. That's a good one. And everyone's like, well, it's not that high a voltage, you know what I mean? It was pretty funny, but a lot of that stuff, is pretty cool. And, it's kind of a shame what's happened with like Facebook and stuff where you can't like joke like that anymore. I'm sure he got put in like Facebook jail for promoting drugs or something like that. But it's just a lot of fun to, kind of mess around, joke around, and we're all adults up in here, and, we're not trying to, tell anyone to do anything illegal or anything, I mean, check the laws of your state, make sure that's legal.
Well, he probably got banned because he didn't identify his pronouns.
Oh,
Was that
that
what
could
the
be.
they, them, he, she?
Yeah,
She,
you never
her,
know.
him?
You have to wonder. You have to wonder. But yeah, so it's a lot of fun doing these every week, and I have a lot of what was that?
Of the week, Willie.
Well, Mike, it's coming up right now, son.
It's time for Myth of the Week.
All right. Well, this is a really interesting one. We were doing a project and I started demoing like the old door mags, the door magnets that hold the doors open.
Mhm.
And it was weird because some of them were plastic. They had a plastic back box on there. And oh, that's pretty cool. That's new. I haven't seen that yet.
Yeah,
Um,
trying to do different things.
Yeah, but so this one here, this is actually a replacement one, and there is no way that that box actually connects to that wire mold. Like, there's no specific connection that actually connects to it. It's just basically a box slapped up there, and that wire mold's just a raceway. And
Mhm.
so there's really nothing physically connecting the metal raceway to the metal box. And it was funny because somebody mentioned if it was a plastic box, then it didn't need a ground jumper. And so I'm like, well, does the metal one need one? And the manufacturer puts an actual, I think it's an 832 ground screw in there that's not green, so that's the whole thing. Like, and it was really hard to get a screw in there because you only had like maybe like a quarter inch. And so and it actually bottomed out at the back of the box. So I had to like cut that screw exactly perfect to get it to fit in there. And then you had to do like maybe a couple extra wraps of ground on there. I
Mhm.
grounded them all, but I was thinking to myself, like, well, this is only 24 volts. What happened to all those people out there say, 50 volts or less, you don't need to do nothing, you know?
Mhm.
And so it's really interesting. There's a lot of things that kind of intersect here when it comes to this because yeah, the manufacturer instructions, am I required to follow manufacturer instructions and install a ground tail? Or does the code just specifically not even cover it at all? And could I just do whatever I want? And the reason I was kind of asking this question is because when I was demoing out the old ones, I bet what happened was I bet they did one plastic one and the guy said, "Don't worry about bonding it." And then when they went and they did all the rest of them, they didn't care. And they're like,
Mhm.
"Oh, well, it's plastic," but they weren't. Some of them were stainless. And so it was pretty interesting kind of question to ask. And it's really funny because I was kind of asking the apprentices, and they're just like deer in the headlights, like, "Bill, I don't know." You know what I mean? And it's just really funny because they're just like, "I don't know." Like, I don't want to tell you yes or no. He's like, a lot of people said, hey, I think it's required. There's a screw there. It's required regardless of voltage. But, it's a pretty interesting question because at 120 volts, that could be parts that are likely to become energized. And when those door magnets, those are energized to hold the door. So those are pretty much 24/7 energized unless the fire alarm goes off.
Mhm.
And so it's kind of an interesting question to ask. And I mean, just off the top of my head, I would say it has a screw hole. Manufacturer requires that jumper. Manufacturer uh, basically designs that as a listed assembly. So you have the door magnet itself, the device that goes in the box, they all fit together, and it's designed to have that jumper in case parts are likely to become energized. I don't think that really has a voltage threshold of class 2 wiring or class 1 wiring. But it's pretty interesting to see that there is a difference. The ones before that we pulled out, they were not grounded and they were 120 volt.
Mhm.
And then we rewired them 24 volt.
Yeah.
So it's pretty interesting, like, I mean, a pretty interesting question. And I see you kind of got a little bit of a write up over there, um, you know, to the right there. And maybe you could kind of go through what your thoughts are as far as what you think would prevail. I'm going on the fact that the manufacturer instructions would override anything here.
Well, let me explain a couple of things first and foremost. And there's some writing there, myth and fact and all that. But the one I like is at the very bottom that I had put in here. Voltage does not eliminate grounding.
True.
That is one statement everybody needs, because I've heard people before, well, it's only 24 volts, it doesn't need to be grounded. No, that isn't true. And I've also put down below it, install in accordance with NEC and the manufacturer's instructions, because you're going to be looking at a few different things. And one thing I didn't put in here, but I like to point out a couple of things. That one of the things that you're looking at is when you get crossed with some current, basically you have to consider is what is the let go threshold. And
True.
current is usually 10 to 20 milliamps. So we're not even talking a freaking amp. So therefore, that's why it's not going to eliminate the need. And usually the let go for a woman is about 10 milliamps, and for a man, it's 16 milliamps. Okay. So I like to point a few of those things out, because once you get to let go, that's where you have muscle contraction. So
True.
it's physically impossible to release from the energized object, whatever you're touching. Okay.
So what is the threshold 4 to 6 milliamps? What is that? That is within the let go threshold, right? And like, is that so that you limit the duration of the shock?
Well, yeah, but that's also the 4 to 6 milliamps you're talking about for a Class A device. It's going to trip the device, so it ain't going to matter anyway. The 10 to 20 milliamps is where you just can't let go of it.
Gotcha.
Okay.
Okay.
So what I did is I put together a breakdown here. So what is the answer? Yes and no. So you sort of have to look at a couple of different things. And what I wrote this one up because I wanted to be a little careful on the way you look at this. So what I said was, be careful not to overstate what the NEC says at this point. Okay. So when you look at the National Electrical Code, there's no rule in there that is a blanket rule that states that a grounding jumper is required on every Class 2 fire alarm device. That's why I showed the fire alarm. Okay. Because it depends the way it's established and the way the wiring methods are set up. So basically, you have a requirement here that depends on whether the equipment is required to be connected to equipment grounding conductor or how the device is listed. And that takes me right back to here, which I was stating here. You need to install it in accordance with the NEC and the manufacturer's instructions. And you could have a device sort of set up like you're talking about here, which I would say no. You see what I'm saying?
Yeah.
So
Well, and that's kind of what I was thinking about. I was like, man, I wonder if I just cut these things off and act like they were never on there, you know? Like who would ever know? And then Joe Courier made a point that you're already getting a metal to metal contact on that. It's a surface mounted metal device, and there's literally nothing bonded to the electrical system.
yeah, it depends on the device in that case. And that's what I'm saying, because the conduit and the box and everything can be used as the equipment ground looking at 250.118.
True.
Okay.
And I think that it was a little sketch the way they had it wired before, because they pulled a full size ground through that wire mold and then they just capped it off. It wasn't tied to anything, you know?
Yeah.
So to me, that's a code violation, because, you know, you have to ensure that that path of continuity. And so that would be where that jumper would need to be connected to that equipment ground and bonded to that enclosure.
Sure.
But in this case, you don't really have any reason to even use it, because it's just a 24 volt class A or class 2 wiring. And I don't even see why it would even matter, because like if it was to become energized to that metal, it would fold the power supply.
Sure it would. And that's why I'm saying it depends on the device. That's why my answer is yes and no. Because it depends on the way what you're using. And that's why I said you want to do it based on the NEC and the manufacturer's instructions. So when you're looking at the myth was a grounding jumper is not required on a Class 2 fire alarm device because it operates at 24 volts instead of 120 volts. That's why I write down here, and I'm looking at the little fire symbol at the bottom. I said voltage has nothing to do with this.
Right.
Okay. So I just wanted to point that out. So then I said, this is a fact that the operating voltage does not determine whether grounding or bonding is required. And then the National Electrical Code, what does it actually do? It bases all its requirements and everything for grounding and bonding on what? The equipment, the enclosure, and the wiring method. And then also the manufacturer's installation instructions. It's based on that. It's not based on whether or not the circuit is 20 volts or 120 volts.
True.
Okay. And that is probably one of the most important parts of this. So what I did is I put a compilation. You know how I am with code loops.
Yeah.
And these are things you can go look at to help address everything I'm talking about. Well, when you look at 90.3, what does it say over there? And you deal with code arrangement. Well, Article 760 modifies the general rules, right? So
Yeah.
it modifies or supplements. And then if you look at 110.3b, that's where you pick up your listing and labeling and using the manufacturer's instructions. And then when you look at the main general rules, it says over in 250.4a, 2, and 3 that the grounding and bonding of talks about what we just talked about right here. Let me go back. Where at the bottom of this, where we go into fact, that your grounding and bonding requirements on the equipment, closure, and wiring methods. Okay. True. So these are your general requirements here for the conductive materials and electrical equipment. And then when you look at 250.110, what does that deal with? That's all your different equipment that's there that's required to be connected by an equipment grounding conductor. Okay.
True. And that's kind of, I think, where this kind of gray area comes into, because there is no equipment grounding conductor for this system. And
right.
And so it's like we're changing it from a system that had an equipment grounding conductor to a system that's absent of equipment grounding conductor. To me, honestly, I went off of 110.3b. And also, I did kind of go off a little bit of 90.3 too, because if you go to 760, what's 760 a lot based on is NFPA 72. And if you go into NFPA 72, it says follow manufacturer's instructions. You know, literally, if you don't have that guidance from any other place in NFPA 72, it just says consult manufacturer. That's it. It doesn't say go look for other areas in this code that could prove you an argument like Weedman always does. You know,
well, sure.
It's ridiculous.
And this is a good example, because when you look at 250.110, that's equipment that's fastened in place, fixed, or the other part is connected by permanent wiring methods. But the one that you look at in 250.110 is 3. That's where it's in electrical contact with what? Metal. Okay. Yeah. Now, the reason I referenced 250.110 and not 250.112, because when you look at 250.112, you got specific equipment fastened in place.
True.
And that's where you get into your switch gear and switchboard frames. You got pipe organs over there, motor frames. You got elevators and cranes. You got garages, theaters, motion picture studios. You got motor controllers. You've got electric signs. And let's see, you got remote control signaling, and then you got fire alarm circuits there. Okay.
Yeah. And they didn't really make a provision. That was the other thing when I was looking at it. I kind of nerd out when I start installing some of this equipment, but they didn't make any provision to where I can make a metal to metal contact with that raceway.
Mm-hmm.
So essentially, it's just a bunch of pieces of metal just floating on brick. And with a 24 volt supply going to it. To me, honestly, I think it's safer with the 24 volt going there than the 110 or 120. I don't know why I always say 110, but I think it's a 120 volt in that situation is going to be kind of more dangerous, because you don't have a electrical continuity of the raceway. you can't comply with 250.110. You can't comply with a lot of this stuff. I mean, and then that's where it kind of comes in. But I think the manufacturer instructions is like way more important than the code, because if you follow all the manufacturer instructions and they say install this to the brick and put whatever voltage to it and ground it the best you can, then I think that that's pretty much the intent of the code. And I think
Mhm.
that's kind of where I kind of was going with this whole thing, is that it's not just a straight up code violation because you didn't follow 250.110.
Yeah, well, see, when you get over and you look at 112 and look at what that gets into, they talk about in firearm circuits shall be ground, but it refers you to systems that have been grounded. So depending on
Right.
what type of system you're coming from, it'll tell you go see part 2, which is system ground, then part 8, which is DC ground. Okay.
Yeah, and I don't even think that there's that much of this specific system that's really grounded. Like we
Sure.
come off with just a 2-wire off a class 2 circuit and just drop her in there, So
Sure. Well,
I mean, it's
and that's
almost
why.
better if it's not grounded from our standpoint, because then it causes problems if it becomes grounded.
Well, and it makes more sense when you look at why I've got it laid out this way in my code book, because the first thing I do is code arrangement and talk about Article 760, because you get into your permitted equipment grounding conductors in 118, and then the continuity of bonding the equipment grounding conductors and boxes and closures in 25148. But then I tell you, this is where you come in. When you're dealing with class 2 circuits, they're subject to what? Other NEC articles
Okay.
that it could be modified. And in
Yeah.
this case, you go look at 760.3. That's where you start getting the modifications of Article 760. And that's where you
Sure.
get into the manufacturer's instructions, which is the second one I have listed. So
Yeah,
there,
and to me, honestly, it was really interesting because I feel you have a couple compelling arguments you could go off of. Like, if you're like, let's just say that you are metallically connected to that wire mold, and then you're applying like a 250/148.
that's right.
I would say you don't need a jumper in that case either, even if it is 120.
Well, you got to remember, it just take like a receptacle, switch something, and you take and you jumper everything and all of that, and you bond everything in. Why do you do that? Because you have metal on that switch. But these little devices, they have like the covers non-metallic, the switch is non-metallic. When you disconnect it, you don't have that exposure at that point.
So I would make the argument in this case that that wire mold is not continuous and listed for grounding.
Well, and that's another point, because when you get into that, you have to go over and you need to look at 250.118, and that's where you get into the types of equipment grounding conductors. And
Mhm.
when you go over there and look at that, you got, of course, you got your conductors, then you got your rigid, intermediate, your EMT, you got your flexible metal conduit, your liquid tight. You got flexible metal tubing, then you got AC cable, the armor of the AC cable. You've got your metal sheet MI cable, that's their MC cable. And then you pick up the few ones that are left. I think you got cable trays, of course. Then there's cable bus, and you got surface metal raceways. But
Yeah, I guess that's a surface metal raiseway, but I don't
you
think it's continuous continuity.
well, what it says over there, and matter of fact, we went over this just a little while back. You'll remember this because I brought this up. I said when it was talking about the service metal raceways, it's the type of raceways that are listed for grounding.
True. Yep, I
So
remember that.
yeah, and you're you forgot about it. You go, oh, I didn't know that. And I said, yeah. But it was for, of course, where you had conductors that didn't exceed 600 volts. And then
Right.
they also had another one in there that wasn't new. It's been in there where it talked about electrically continuous metal raceways and listed auxiliary gutters. And I would say that's not considered an electrically continuous metal raceway.
True.
I would consider that a surface metal raceway, but it has to be the type of raceway that has been listed for grounding. So
True, and it's really hard for me to remember all this stuff like you remember. So that's why I do like man versus machine, so I can make sure you remember it. So I make sure we both remember it the same, so that you
Well,
remember it, then you can remind me.
this is interesting because you remember when we were showing this, was it about a month ago, I guess?
Yeah.
And I showed one and I said it looks redundant a little bit, but we had one that was metal and one that was non-metallic. And
Right.
that we were showing the two different setups. And that's when I was talking about the one being listed for grounding. And it didn't seem like much at the time, but then you bring something like this up. Now it makes perfect sense why we went through and took the extra time and everything to show you exactly what all the, and if you remember, we showed the fittings and everything and showed the back tracking and all of that, how it would be mounted to the wall, where the hose would be located and all that. So,
Yeah. No, that was a good illustration. That came right out of your book, I think.
Mm-hmm.
And what's so cool about this is I always want this to be like apprentices to not be scared to ask questions, because what happens is I'll ask the dumb question, then King James will rip me up live, and then you guys don't have to worry. I'm asking the question for you, and so that's what makes it fun.
When I look at this, you know how I am on everything.
Uh-huh.
Everything has to be broken down, and sometimes I may throw 20 sections at you. But the reason I do, because then you start getting a better understanding. So,
and I feel you're using the code as a whole, and you're kind of teaching guys to fish too, rather than just be like Weed Man and just say nope, can't do it.
Well, you know who got me doing that? My dad.
Your dad, probably.
Yeah, he would just tell me, hey, you need to think of this and you need to think of this. And it started making me think, because I just like everybody else, I just go find something in code and I'd be like, oh, there it is. But there may be something else you need to look at. So as a good example, when you're looking at this and you have a class 2 24 volt circuit, that does not automatically mean you're going to eliminate any grounding or bonding requirements. So that's where I put in here just to sort of finish this off. If the metal box or equipment is to be grounded, or if the listed installation instructions require grounding connection, those requirements still apply. That's it.
True. So, yeah, and the thing is that the manufacturer requires the equipment to be bonded. It doesn't require it to be grounded.
That's right.
So that's kind of the distinction I wanted everyone to get. And so don't be just cutting those grounds off and throwing them in the trash. And you might have an inspector like King James come through and fail your whole inspection and post you and send you a link to the myth of the week. You never know.
I will tell you this. I remember when I was chief there in Grapevine and they get in to start asking me questions. I'd be out there, I'd call something and I'd go, well, let's go look here, look at this, look at this. And then it got to the point after about a year of me doing that, they didn't even argue. They go, okay. Because I'd show them in the code, and trust me, I've been out there, and it's for any inspectors out there. If you know your code and you're showing it to journeyman, master, contractor, engineer, and explaining exactly what you're looking at and your reason behind it, they ain't going to argue with you. They're going to be like, I made a mistake. I agree with you. They're not going to get mad. If you just go out there and just tell them, because I said so, that you should always be able to back up your point. And I'll tell you, when I was chief, there was probably, I'd say the whole time I probably had 3 or 4 times I was unsure of something, but I knew who to call. If like, I remember we were doing one, I was unsure about something, and Dad, he goes, I think it's it. He goes, well, I'm not sure. He goes, let me call so-and-so. He was an expert that was on one of the panels. He called me back and sent me all the information and everything. And I took it out there and it said, this is why I think this, and this is the information. They're like, that's good with me, but I didn't know everything. And that's one of the things I try to tell people in the industry: get to know people and get their cards and stuff. Cause eventually there might come a time, you might not see that guy for 5 years, and you may call him up and say, hey, I got this card from you a long time ago, blah, 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 and I'm having trouble with this. And if they don't know, they might send you the right person to go to.
Yeah, and that's a good point too. Like a lot of that comes into kind of why I wanted to do this myth of the week, was because I would always just kind of ask these questions, and you'd get so many different varying opinions, and you'd have, there was a lot of people that said you don't need ground, you don't need that bonding jumper, you just cut it off because you don't need it. Well, you probably don't. But we're trying to do this as a code discussion. We're not trying to do it as a what I would do because I don't care or whatever, or this is never going to cause a problem. And that's where I try to elevate this to like just a code discussion and not what King James would bust on an install, like or what I think I could get away on an install. Like, honestly, I bonded every single one of them. I got screws in my pouch and I bonded every single one. I cut them the exact length, perfect. I put enough copper around them to get them tight. I tucked them in there nice to where they wouldn't get hit, and it was real easy. It was like took me 2 seconds, so it wasn't like anything that was really hard, But I thought it was a good question to ask because, if you just tuck one in without a ground on it, is that a big deal? I don't think it is, but it's not if it's a big deal or not. It's what does the code say? What is what are we trying to do as installers, and what kind of standard are we trying to live up to as far as complying with the manufacturer? Like, we want that manufacturer to come out there and be like, that's exactly how I wanted it installed. Okay, cool. There might not even be an equipment ground. It might be totally pointless, but at least if the manufacturer signs off on it, then that that's what they're trying to do, and they actually think that you read the instructions too. So it's kind of a bonus. But myth busted. I say you need it per manufacturer instructions. I like your answer of yes and no. Yes, you need it, but no, you probably don't. So it's pretty cool. I like it.
It all depends on the type of installation. So
true.
That's what it comes down to. All right.
I agree.
Let's roll right on into topic.
All right. Nice. Dude, I want to just tell everyone out there, if you blast through these topics of the week really quick before you go take your continuing education, it'll make it so much easier. It was a lot of fun. I blasted through that continuing ed.
Yeah, we've actually done a pretty good job on this, going through and sort of laying everything out for everybody to look at. And I just sort of feel like going through ever change. How many did we do? Like 217 changes or something like that. We did quite a few.
I don't want to quote a number because I don't want you to end up owing me some changes again, but I'm just kidding. But
I'll say this.
I think it was like around 220, I want to say.
just looking at things like this, like we show you a good example here. This is doing recondition of equipment. Okay. And this in here is going to be dealing with your low voltage lighting. And it basically just tells you there that any of your installation of your reconditioned low voltage lighting systems or any lighting systems assembled from reconditioned parts shall not be permitted. So what I'm getting into that is when you look at this recondition here, we're showing like where you have an oscillating transformer here. And we're actually showing you the new stuff because this one here is a digital type. And then we show you the type of panel that you would see that set up when they're doing all these low voltage lighting circuits and systems and everything. So we tried to put something together that gives you a look of what you would actually see out in the field. So a lot of effort and time went into this. And then of course, when you look over there, they're also going to have the one for permitted to be reconditioned. And 411.3A, that's going to be a reserved also. So basically you can't do it on any of them for right
now. Like, and that's going to help out a lot of like the younger service guys when they start coming into that stuff and they're like, oh, I don't even know how to troubleshoot this. And so then that's going to be kind of the next step that, feel free to like reach out to us and be like, hey, I saw a system I never seen before. Take a picture of it, send it to me. And we'll go over it. We'll cover it and, kind of analyze that kind of stuff. So that's really cool.
Mm-hmm. And then this is, well, we had talked about this the other day, but this is where when you go over and look at 422 and see, this is once again where they come in and they did a few little different changes than what we were expecting. But, when you go over there and you look at your general requirements for your appliances, and these of course are the appliances that are 150 volts or less to ground, and they're 60 amps or less. So, and that can be single or three phase, but that are required here to be provided with what? Class A protection. Okay.
Yep.
But the thing I like to point out also there, they have a little sentence on there that talks about multiple Class A protection devices shall be permitted, but shall not be required.
Yeah, and that's kind of interesting because I heard a lot about some of these companies actually putting internal GFCI in there. And I've submitted on several attempts to make it to where regardless if it has internal GFCI, then it's done. And it just keeps getting rejected, and I don't know, it's stupid.
Well, where did they do that at?
So what I tried to do,
I'm talking about in the new code.
Where you're saying that they do that?
Electrical vehicle.
Yeah, 100%.
So see, they got protection there to protect personnel when they're plugging in them devices. That's why they went back and deleted all that stuff they put in. They realized they had a mistake. To me, this little sentence right here, where it says multiple Class A protected devices shall be permitted, but shall not be required. If it's internal to any of these devices listed here, or this equipment, the automotive vacuum machines, your drinking coolers, your cord and plug connected high pressure spray washing machines, you got your tire inflation machines, vending machines, sump pumps, and dishwashers. If any of those have internal, no, you don't need it.
Yeah, and so the reason that this is kind of big and the reason I kind of pushed that really hard for 2026 was because the reason that Code Making Panel 2 does not like this is because they can actually put an internal personnel protection that's tested and listed for compatibility with their equipment. And they didn't like that because, and we, when you mentioned the EVSE, that was a big thing because this EVSE equipment has been sold and tested around the world with zero incident, and now all of a sudden the National Electric Code has a problem with it.
Well, I want to explain something here. And this is interesting because, and I've brought this up before, and of course you got people like Jeremy and them over there. Well, you still need on the circuit. And I'm like, see, this is where I have a problem. Because, like I've always said, I take the code as a whole. So if I look at 422.5b, and that's your typing location, let's see what it says. It says the GFCI shall be readily accessible, listed, and located in one or more of the following locations. So they tell you in one or more, but I want to go back up before I read that, because the last sentence in 422.5a says multiple Class A protected devices shall be permitted, but shall not be required. Okay, now
Yeah.
I've already gotten it, and if you want to argue with Jeremy, just bring this up again to him and lay it out.
I thought we were trying to protect that the premises wiring leaves the.
Yeah, but I want you to bring this up to him and say, here's what it says. Now argue. So when I go look at the locations that are permitted, let's see what it says. It can be within the branch circuit overcurrent device, so at the panel board. It can be a device or outlet with a supply circuit. Okay. Now that's interesting because I've never heard an outlet that actually provided GFCI protection. I've heard of devices that do.
Yeah.
So that's interesting. Then it said an integral part of the attachment plug, or it can be within the supply cord, not more than 12 inches from the attachment plug. And then this is the one that you want to use, Bill. Factory installed within the appliance.
Yeah.
So they just
100%.
gave me the permission to do this. And then I can go back up here and look at 422.5a, and it says it shall be permitted to put it in one of those other ones. But if I have it there, then the other one's not required.
Yeah.
It says shall not be required.
So how are you putting a standard thermal mag out there to that equipment that is already listed by a manufacturer? And that's what we've been saying this whole time. And
basically what I like to say in this case, they just proved our point.
Yeah, 100%. And the other thing is too, when you look at it, it doesn't tell you what threshold this personnel protection is because it's set by the manufacturer.
Okay.
And that's the reason why Code Making Panel 2 got so upset with Code Making Panel 17. So Code Making Panel 17 does the code requirements for the appliance. And they actually kind of got beef a little with Code Making Panel 2 and said, you guys protect the branch circuit, we'll protect the appliance. And
this is what I want you to do next week. Okay. I want, and I don't care which one you pick out in 422.5a. You can do, let's just say we do a bottle fill station, or let's say a tire inflation machine, or vending machine's better. So let's do a vending machine. This is going to be the myth next week.
Okay.
If a vending machine has internal GFCI protection, do I still need GFCI protection upstream?
Yeah. I mean, of course, we knew he was going to show up at some point.
No. Hey, Jeremy, I just read that too. Well, we're going to do it next week, but you're more than welcome to answer it this week if you want. If I have GFCI protection installed internally at the vending machine, do I need it upstream at, say, the receptacle or at the circuit breaker? Simple yes or no. That's all you have to ask. because I'm going to show you now.
I
Yeah,
think he's saying I think he's saying yes.
he puts in there because he's not smart enough to answer that. That's what you do when you've been caught, and we're showing exactly where the problem is, because it specifically states in let's just go back. 422.5b says the GFCI shall be readily accessible, listed, and located in one or more of the following locations. Factory installed within the appliance. Okay?
Oh, now all of a sudden we're picking and choosing. Now you don't need it all of a sudden.
No, if it's in a mini. Oh, no. You told us. Oh my God, this is.
Oh yeah, so you're just picking and choosing whatever you feel like now.
Yeah.
The EBSE has internal personnel
It's
protection.
the same thing. It ain't no difference in it. In the way you're providing personnel protection, just like we tried to. See, now what he's upset with, because you told us it didn't matter. That outlet had.
Oh, he can't get his point across now, so he wants on the show. You're on the show, Jeremy.
Yeah, you're on it right now. But let's just stop right there. It says factory installed within the appliance. So, in other words, what y'all are witnessing, everybody that's watching the podcast or watches it later, he's about to be caught, and he's going to have trouble arguing what's going to happen here. So now, if I go back up and look at 422.5a and the last sentence in that first paragraph, it says multiple Class A protected devices shall be permitted, but shall not be required. So now if I go back down here to 422.5b and I pick up my typing location, and if I have it factory installed within appliance, then I don't need it upstream.
Sure. And that is why the Standards Council reversed 62554B.
This is so awesome, everybody.
Yeah.
Everything we've been telling y'all this whole time is coming true.
100%. And Weedman's just crickets now.
Yeah, and what?
Like crickets chirping.
What was it the other day? Ryan had been telling, Mr. Expert, he'd been telling everybody, oh, you got to have GFCI protection for that.
It doesn't matter, Weedman. That vending machine could have SSCI and it's still legit by this. It doesn't tell you it has to be a Class A device.
Okay, let's go back. It says the GFCI device shall be readily accessible, listed, blah, 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 factory installed within the appliance. And then you come back up and you look at 220.5a. What type of device were they talking about? It says multiple Class A protected devices. I mean, in other words, it's providing the protection for who, Jeremy? Oh, that's right. Personnel.
Who's lying? I don't get where you get this lie. We're reading what the code says, dude. How are we lying about the code?
Hey, everybody that's watching, this is a guy that basically said Texas was the armpit of the United States, which is unfreaking believable.
And he's just going to go blah, 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 because you're just a typical liberal, typical Democrat just losing the argument.
This is what they do. They call you names and everything when you're showing the truth. All I ask anybody is just go look at what we're giving you, the sections. You go look at it, read it, and then you tell us what you think. You don't have to take our word for it. We're just showing you what it says and what our opinion is based on what the code is saying there. And if you notice, he's not arguing what it says. He just says y'all are liars. That's what they do when they're losing an argument. And they've been calling us names now for 10 years, just saying, your publications suck. You and Bill are idiots. Blah, 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 morons. I mean, and you can come on this show and be in the comments or he'll call you names.
Oh, yeah.
I mean, that's happened too. And so everybody, everybody's waiting. You have one views and it's me. Oh, wow. Well, Jeremy, a lot of people, they got things going on during the day and a lot of them come watch it after the fact.
Yeah,
And
I mean,
but
Daniel's
there's
probably not even home from work yet.
but
I
there's
guarantee he'll be here.
but there's 8 over on Rumble, Jeremy.
Oh
So
yeah, I just looked
it
over there. That's right.
yeah, there's other places that it goes to. It just ain't here. And people are starting to realize now that the mob rule of Jeremy and the ECD boys, nobody's listening to y'all anymore. You know, it's funny because I actually went over there and I'm not going to tell them who I am, but I got on there just and I don't ever comment nothing. I just and there's nothing going on over there. Nobody. I mean, that place is dead as a door now. And the reason is because people found out y'all are nothing but a bunch of liars.
Yeah.
And you attack anybody who disagrees with you. And but it doesn't matter. See, that's what they do. Show me the views. Show me how much money you make, how many copies of books you sold. I ain't showing you anything. I don't have to show you anything. Just put it this way, Jeremy. I'm doing perfectly fine and I'm happy.
Yeah,
That's all you need to know.
He can't stand it because I'm out at DIA just having a great time. And, you know, like this is like the best job of my whole life. And so, you know,
Yeah. I mean, it's like mine. I feel like I've got the greatest jobs there ever was. But
yeah.
I love doing what I do. And I love learning the code. I've learned all these other standards. I mean, I've done stuff for OSHA, and I know OSHA standards real well. I've been on the 70B committee, the 70E committee, the EECA committee that covers 496, 497, and 499 for hazardous classified locations. I've done all these different committees, been on there. I've been on for a long time. And
At least I don't have to read the prints to find out what the job specs are, Jeremy.
well, see,
Dummy.
he'll sit there and say I'm a fraud, but yet I've done all this stuff, and he's never done anything like that. But yet he'll call everybody else a fraud that's actually been out there and done something. I mean, for people that don't know, I mean, I was an instructor for NFPA for 30 years.
Yeah, and nobody ever said the calculation was wrong until you came along, Weed Man. So, what, you think you're like special or something? You know?
And see, that's another thing. He brings this up constantly. Let me explain this to everybody that's watching. NFPA used to publish our publications. They paid for the right to do it, first of all, and then we agreed terms and all that. They wanted to go through and edit it because anything they were going to put their name on, they wanted their engineering staff and stuff to go through it. And this calculation he's arguing about, nobody disagreed with it. But yet, everybody should listen to somebody that just teaches apprentices. And therefore, since he teaches for the union, he thinks he's smarter than everybody else. Just to let you know, Jeremy, I taught for the union too when I first started. And it was local 116 in Fort Worth. But then again, y'all have to remember, I was just
you don't have any proof of that. Oh, I forgot about that.
But I just happen to know the local, and the Dallas local was 59. I actually went over there and filled in a couple of times also. And I was teaching 4th year. You know why they had me teaching 4th year, Jeremy? Because I knew all the calculations and everything. And that was the hardest part of passing the test. And I've been through the union, Jeremy. I went through my 4 years and everything. At that time, it was called the NJATC, the National Joint Apprenticeship Training Committee. You can go look it up. Of course, I have to show proof on this, even though I know the names of everything and when it got started. And to give you another little update, Jeremy, my grandfather was actually the one who helped set up and brought the union to the city of Fort Worth over here, and he was on the board of education there over at the school also, and the name of his company was Harry White Electric. Now, when my dad married my mom, it was actually my grandfather that got my dad into the apprenticeship. So, you know, my roots go way back, and I've come up through it. I know exactly from listening to conversations with my grandfather and how they did things and all that. And back at that time.
Well, by that timeline, what I'm guessing is your dad started teaching in 1969.
No, Dad really.
Just kidding.
Well, that would be pretty close since I was born in 63, if you wanted to look at it when he started. So, I mean, going by Mike's timeline and everything, Dad started teaching in 63 because he'd have been an apprentice like Mike was.
That's so
So
funny.
See, look at this. This is unbelievable. Your grandfather is an idiot. Now, see,
I know.
let me explain something there to everybody's watching this, because this is uncalled for.
The only reason why he's saying that is because he doesn't like Texas electricians.
Oh no, he called us all glorified ditch diggers.
Yeah.
But to call my grandfather an idiot, who had I think he was the second biggest contractor in Fort Worth at the time. Somebody that had his own business, built it up, went through the process and getting the union here and getting the adoption, doing all the papers and everything. That guy's an idiot. But the guy that teaches for an apprenticeship that is with the union, but's never done anything to help the union grow like that, and try to go out and recruit and bring membership up and all of that, that guy's the idiot. That goes to show you the nonsense you have to put up with people like Jeremy Weed.
Well, he's in this elitist white boy country club, and he just shows his true colors every time he comes on here. So we'll continue on with your topic.
Yeah.
He can contribute if he wants.
Well, this one's going to deal Article 424. This is your fixed electric space heating equipment, and they basically have the same thing that's there, but they tell you it's permitted to be reconditioned for equipment that's being permitted to be installed, except for what is indicated in 424.3b right below it. And basically what it says, reconditioned electric space heating cable shall not be permitted to be installed. So it's just the cable, but if you have some equipment and things like that possibly could be reconditioned. Okay.
Yeah,
so,
I mean, that one's kind of interesting because I wouldn't want reconditioned concrete cable.
oh no, hell no, you wouldn't. I wouldn't either. But it just gives you an idea as you walk through this, the things that they look at. Now, there's going to be a lot of these here. So and I'll do them a little slowly. So when you go look at 426, okay, we're going to get into these conductive pavement heating systems. All right. So like when you looked at this one right here, this is getting in the reconditioned stuff here. But when you get over here, this is where you need to really start looking at a couple of things, because when we get into this fixed outdoor, basically, I like to refer to it as de-icing and snow melting equipment. That's the way I still sort of look at this. Okay. And when I pick this up and I go look at A and B, you're going to get your prohibitive locations here. Okay.
Yeah.
But one thing I do want to point out as you're looking at this is there are a couple of things that you get into where you got your installation requirements. And when you go over and look at that, that's going to be over in part 2. There really wasn't a lot that was done there per se, but you need to make sure that you're looking at that before you start getting over here and you start looking at the rest of this stuff, because it's going to sort of tie into this, because this is going to talk about the conductive pavement heating systems. Okay.
True.
And they're going to tell you that what are the types of locations it's prohibited to go in. So naturally, one is going to be in hazardous classified locations.
Well,
and then
yeah.
the other, of course, is going to deal with Article 680, where they're going to tell you it's prohibited in swimming pools and spas, fountains, locations like that. Okay.
So I have a good one that is a hypothetical myth. So let's just say that I have this heating cable and I stub it up to 24 inches to put my thing in. Am I in the classified location still? Like, just let's just say it's classified locations 18 inches above finished floor.
Well, let me explain why you wouldn't, because you got to remember, you got to look at your different type of ignition points and stuff for different types of chemicals that you could have on the floor and stuff. And if
Yeah, but
you,
I'm inside the wall all the way till 24 inches.
but I'm talking about the floor.
Yeah, well, yeah, I see
Yeah,
that you're not installing it in the classified location, but I'm saying like let's just say that you're technically, let's just say you have like a dock that's outside and you install it in this dock and then you stub up inside the wall and then you come up to 24 inches. The inside of that, let's just say it's a garage bay.
that
The
has
inside of that garage bay is technically a class 1 div 2 location, but you're stubbed up above that location.
that's different
Okay.
because first of all, I probably wouldn't stub it up inside. I'd probably come from the outside up the wall, outside
Yeah.
in, turn it in. But if you
Okay.
did that, then you'd have to look at what the location is inside and make sure you're not within the hazardous classified location.
True. I was just kind of giving a hypothetical. I thought it was pretty interesting.
Yeah. So then the next is 66A through C. And now I do want to point out one thing. We didn't put much to this, but right before you get to 66, you're going to have 64, and that's going to deal with engineering. And the reason I want to point that out for one reason only, because when you're dealing with this, the first one is going to talk about where you have site specific design, and you get into there's two parts to this, and this is why I want to bring this up. One talks about the pavement material design. Okay. And then when you get down the next, and it's going to talk about electrical design. Okay. So when you look at the pavement design, it's going to tell you it has to be designed by who? A civil engineer, a licensed
True.
civil engineer. And then it has to be designed for the specific installation site and it's going to stay within the limits of the listing. Okay.
So
And
there's a really good reason that I like this. I've actually installed some stuff of this before,
mhm,
and all we're doing, they basically said, we're providing the material. All you gotta do is just slap it in
mhm.
and hook it up. Well, you know me, I kind of nerded out, and I wanted to see what it was all about. And they give you an ohms per foot, and so I figured out that one of that runs. So let's just say you show that squiggly line in there, and
Mhm.
that's 400 foot.
Right.
Well, that's what's permitted for that transformer, for that power supply, for that run.
Mhm.
And it was really funny because they went like 500, and I was like, you got to have another power supply, and you got to do another run, and they're just like, nope, we're gonna do it. And that civil engineer stepped in and was like, nope, you're right. It can only be 400 foot long.
Mhm.
It could be under 400 foot. It just can't be over 400 foot.
Sure. And that's why you got a civil engineer that's going to be looking at it. And
True.
another thing I'll point out when you're looking like this illustration, this is a good illustration because
Yeah.
what they do, there's like a little mat that rolls out that they roll underneath it. And you'll see it's got like these little round things with little notches down, and this cable sets down inside it.
Right.
And then that's what they're going to pour over. So we tried
Yeah.
to draw it out so you would have a little bit of idea what it looked like. But the
Yeah, we
interesting
call those things chairs,
yeah, they're like chairs, but
because what they do is they position that cable in like the middle third of the material that's going to be poured,
sure it does.
and that's like ideal where you want it to be mounted.
You know, that's why I drew it in the first place, because a lot of people
Right.
never seen it before. But
Mhm.
when you're dealing with electrical design, it says it has to be done by a licensed electrical engineer. Okay.
True.
But now the interesting thing is, right after you've done all that, every bit of this has to be documented.
Yeah.
Okay. So when they do the design, the testing, and the compliance of the system, it has to be available to who? The owner and authority having jurisdiction. And then, like you were stating a while ago, part of that documentation has to include what? The electrodes. So you
Yeah.
also got to put in that documentation what the material type is, the size, and where the placement of those electrodes are that meet up with that ohm rating, like you were talking about.
Yeah, and it was funny because I just nerd out on that stuff sometimes, and I can't remember. I got like an ohms per foot, and I measured it or I ohmed it, and I had to measure it because we have to measure it, then we have to ohm it.
Mm-hmm.
But it measured fine, so it was clear of any faults. And then I ohmed it, and I was like, wow. I was like, it was, to me, it was a little bit over 500 foot.
Sure.
And so then it was crazy. It took like months. Like it was crazy for them to like review it and everything. They must have had like some kind of wheel they went out there with and measured it, or what, I don't know exactly what. But then they're like, "Yep, we just got to go ahead on that project. They're just gonna do the same, like you show that squiggly line. They're gonna do
Mm-hmm.
that same squiggly line, but they're instead of 12-inch separation, they're gonna do 24-inch separation or something."
That's right. That's
And
why it all has to be documented.
yeah, and then I was like, oh, all right. And then so all they do is they put it in there, and then I ohmed it out then, and I measured it and everything. It was all good. And then I was like, and then I give them the say so that they can pour. So I'm like, yep, it's good. It's good to go, and go ahead and pour. But it was crazy. Like it was some kind of government thing, and it took them forever, man. Like it was crazy. Like I didn't think they were gonna call us back. I was like, I guess they did like it or something. I don't know. Called somebody
Sure.
else. Next thing you know, they're like, "Hey, when can you come out here and hook that up and do the same thing again?" And I was like, "What?" And so then, yeah, I did the same thing again. Went out there, measured it, and then ohmed it, and then I was like, "Oh, you got like 390 feet now," and they're like, "How'd you know?" You know, it was like I was like
Sure.
almost. I was like within 2 foot of what they said they exactly installed.
Sure. And the reason that we didn't do the illustration on 64 is because when you look at 66 and you look at the installation, guess what it says? That conductive pavement hitting system has to be under the supervision of who? The design engineers in accordance with 426.64. So that's
Sure.
why I brought it up. Now, the next part of that is going to deal with the commissioning of the system. Well,
Okay.
guess who has to conduct or do the witness of that commissioning? It has to be the electrical design engineer.
I can agree with that.
So
That's what I think. That's who was with me, like commissioning that. He just
Sure.
wanted to make sure it worked, and like I wanted to do all kinds of cool stuff and just want to see stuff melt and blow up, and you know,
Sure.
you know me, I wanted to, like put a ice block on there and melt it.
Now you can look at this next, and I'm not going to get into a whole bunch of this where the 68 is going to deal with over temperature protection, but the one I will point out is going to be 426.70, because it's going to talk about the electrode cover, and it says when you have those electrodes in there, when they're embedded, it has to be covered by not less than 2 inches of conductive pavement
True.
on top of that electrode.
Yeah,
And
and
then,
that's why they go into like the middle third. There's really no way for me to ensure that that's going to be 100% 2 inches of cover, because a lot of times what that does, it floats in the pour.
well, that's why
So
you put them in those, the bottom I'm showing there. Where,
yeah, it's really hard. It's really hard to describe when you actually been out there and done it. You put these chairs on the dirt, and you actually tie this material. You have different ways of tying this electrode to these chairs, but the chairs will still float. You still have to go and push them down and get them pushed down to the ground while you're pouring because they'll float. And that was my job. And usually I'd have a first year that could see what's going on, and then I just have him push them back down as they're pouring. But
Well, see now,
usually they'll float a little bit when you pour.
see these mat things that they have. That's why I drew this one. Is because those mats that they place down on the ground, it actually locks it in so it stays at 2 inch with 2 inches.
Yeah, it depends on the system that you're using. The one we were using was like under engineer supervision, and there could have been like maybe a better product. Like I don't think that mat thing was available at the time we were doing ours. 'Cause this
It
was
may not
actually
have
probably
been.
probably like 10 years ago, probably when it first came out.
Yeah,
But
well, and see, and that's interesting because when it talks about those electrodes and those supply conductors, when they're within that conductive payment, it literally tells you there that they're required to be supported and secured by some type of non-metallic means.
yeah, and that's what we did. We put like non-metallic chairs in there.
Did because the next one they're going to talk about, but did y'all take into consideration for any type of expansion or contraction?
Yeah.
Okay.
Yeah, I mean, it like pretty much whatever they told us to do on the install, we did the best we could.
Yeah.
I mean, it's hard when they're just pouring concrete on top of them,
Sure.
and those concrete guys do not care,
Right.
So like it doesn't matter. Like it's really funny when you see like the NEC say must be encased in no less than 2 inches of concrete. Like those concrete guys don't care about our code. So we're the ones that have to be out there caring about our code and making sure that's much concrete on top as possible.
Sure. Now, one we did cover is 76 here, and he'll get in and talk about the electrode supply conductors. But the main thing behind this and your sensor and control conductors or any other electrical equipment is there cannot be any type of metal raceways that make contact with a conductive pavement. So
I agree 100% with that. That's good.
Right.
We just PVC'd it.
Yeah, that's what it tells you to do.
Yeah.
Use non-conductive or non-metallic raceway. So
I don't see why you wouldn't use PVC anyway. It's cheapest, easiest.
well, sure, but that's why we did a few different ones here because there was a lot of things here that people hadn't seen this to give them an idea of exactly what they're looking at and what they're required to do. And as a good example, this in here is dealing with your electrical connections. So naturally, what you're getting into is where you're dealing with electrical connections to what? The electrodes. So when you're doing that, how do you make those? Well, you're either, excuse me, you're either using exothermic welding or an irreversible crimp type terminal.
Right.
So those are what you're using. And of course, after inspection, the connection to that electrode is not required to be accessible, but before you pour, it has to be accessible for the inspector to look at.
Yeah, and that's another thing that I think is cool about like when you start getting like these relationships with inspectors, like it's really cool. Like when we were doing some of this stuff, the inspector's like, dude, there's no way I'm gonna make it by that pour. Can you just snap me a few pictures and send it to me before you pour? And I'd be like, yeah, and he'd look at it, he'd be like, dang, he's like, how'd you do this and how you have this tied in and he'd ask me a few questions and I'd be like, well, we did this, this, and this. He's like, you know what? He's like, just be real careful when they're pouring that, do this or that. And I'd be like, all right, cool, And he didn't have to show up. And it was really cool that he trusted me, that the inspector trusted me to just do it right,
Sure.
Like that meant a lot. It was like really cool that he's just like, I need to come out there to look at that. He's like, just do your thing, Bill. He's like, I trust you. It's like, all right, cool, man. And I love it. I've had this happen a few times out of DIA where the inspector's like, well, if you're good with it, I'm good with it. And I'm like, really? I was like, okay, So that meant a lot that the inspector put his reputation on what I thought was a good install.
Sure. And, when we're doing this, it may take a few illustrations to do this, but, we want to make sure that you're hitting the highlights here. And this is another good one. That's really, you got some other section here, but the one we want to focus on here is 84. And it says any of your anchors, fasteners, support hardware, structures, anything like that, guess what? They have to be non-metallic too.
Right.
So, and those are very important things to sort of put this down so people know exactly what they're actually getting into.
Sure.
And then that brings me over to 430.22H1 through H3. Now, this one here, it's probably a little hard to see. Anybody watching this, you'll have to go back and increase it so you can see it. But when you get over and looking at H, what does H deal with? Well, this is going to be new. It's going to deal with your design B, E, and CE motors. Okay.
Right.
And when you look at this, when I get ready, matter of fact, I'll just read it and I'll break it down so everybody understands when you're looking at this. So it says conductors that supply a single design B, E, or CE motor used in continuous duty application are required to have an ampacity of not less than 125%, of course, of the motor full load current rating. And that's determined as provided in where? 430.6A1. And when you look at 430.6A1, what does 6A1 deal with? Well, 6A1 is where you get your conductor ampacity rating and all of that. But when I'm looking at doing getting the amperage for my motor, I don't use the nameplate. I have to use what? The table value.
Right.
Okay. So
there's no minimum. There's no minimum. There's no minimum. Ridiculous, man.
What gets me when he starts making these type of comments here is when you get in to doing these calculations, one of the things, and I remember this, we've actually had, at that time we had SBCCI, I think was the name of Southern Building Code. They were actually using our books to design their test, and so was the other one, ICDO, I think it was. And the reason I know that, because they used to come to the inspector associations and the IAI that we used to go to, and they would tell us this. Now, one of the things that they had done, if they asked a motor question and they wanted to know the minimum, it was exactly the way we put it in. And the other thing I find interesting about that is NFPA, who published our publications, we've had that in there for God, who knows how long. Now,
I knew it was coming. I knew you'd have to say it.
So, well, you got a starting point. And but let me explain something here. If I go over and let's say you go look at table 430.52C1, okay, just to sort of lay this out there, basically, you understand it, and you'll understand after I explain it that Jeremy doesn't know what the hell he's talking about. So when you go over and you look at that table, now first of all, let me start this off right here. Well, he can get mad all he wants because I'm telling the truth for everybody to follow.
Huh?
If you go look at 430.52C1, that's where you're going to pick up your rating or setting. And when you look at C1, the title literally states in accordance with table 430.52C1. Now I'm going to read it to you. And then you can make the decision on what you believe here. Okay. So it says a protected device that has a rating or setting not exceeding the value calculated according to the values given in table 430.52.1c shall be used unless otherwise permitted for the next size and maximum size, which is 430.52c.
Not a maximum size cable, weed man.
So I have a protected device or rating or setting not exceeding the value calculated. So if I can't exceed what the value is that's calculated, then that means I have to drop down the next standard size. Is that correct?
Yeah.
Or starting 100%. Point. That would be a minimum starting point right there. Now, I can go down below that if it'll allow the motor to start or not, but I'm setting up a point here. So I've got a minimum, next, and maximum size. Now, before I go any further, I'm gonna give another example on something that I want everybody to pay attention to. All right. Now, if I go over and I look at 440.22, that's where you're going to get to your application and setting. And what does it say over there? Well, if you look, it says the motor compressor, you got your branch circuit, short circuit.
Oh, wow. Weed man's agreeing with you now.
Well, hold on a minute. Shall be capable of carrying the starting current of motor. Then it says a protected device having a rating or setting not exceeding 175%. So I can't exceed, so that means I got to drop down. Now, it doesn't matter to me if it's an AC or a motor calculation here at this point. The only difference is I can't exceed the calculated value and the percentages can be different. Okay. Now, how many, if anybody's ever seen this before, have you ever looked on an AC unit and saw on the AC unit nameplate where it had minimum and maximum size hacker breaker size?
100% I've seen that.
Okay, now, if that's the case, Jeremy says there's no such thing as a minimum, but yet you got a manufacturer that has a starting point there that tells you it's got to be this size. Now, that's
nothing. He's not saying you can't go lower than 175%. So
I'm
stupid.
not. Matter of fact, I just said you could. I said it's a starting point, Jeremy. And everybody has agreed with the way that we established. I mean, NFPA published our books, and the reason they did is because what we were stating was the way you do it. I mean, I don't know how to say it. They agreed with us, but I'll just make a problem up here. Let's say that I have I'm on a size and invoice.
Not saying it's a minimum. It's a starting point. It's not a minimum requirement.
Yeah, you can still go lower, but most people on a test, Jeremy, they'll say, "What is the minimum size?" And I'm going to do it like something you would see on a test. So let's say they ask you, "What?"
I don't know. I think you're having a hard time understanding what we're talking about, weed man, because nor are we saying that NEC limits you to 175%.
Here's a good example. What percentage, Jeremy, if I look on an AC unit and they have a minimum and maximum size circuit breaker there, what percentage do you think they use to make that determination? Oh, I can tell you, because if you look, when they do the listing and labeling of that equipment, and they actually put that nameplate there with all the other information that's required on it by the NEC, they have to take and look at the NEC to make an assumption on something. So for them to be able to put the minimum size hacker breaker rating, they had to get a percentage from somewhere. Well, I guarantee you right now, Jeremy, I know 100% fact they got it from the National Electrical Code. And
the ones that do follow that rule of you start at a minimum.
That's right.
So if you can't go lower.
So they use the 175%. And of course, they were able to do that because by OSHA, whoever the listing and labeling agency is, all updated electrical codes, Jeremy, and installation standards. OSHA tells them they have to do that. And I've broken this down so many times to prove all these spots. But you being the type of person you are, Jeremy, just because you're getting proved wrong, you have to come on here and start calling people names and everything. But I'm going to prove this point one more time. So let's say,
Yeah, and it doesn't matter. The ones that don't are fine. Like, just put it at the maximum. You're never gonna have a problem. I just don't see what the whole point is arguing.
well, they give you options. Well, here, I'll just do a problem here real quick. I'm just going to make this up on top of my head. Everybody just follow on as you can. I'm just going to do it real quick. I'm going to do it off the top of my head. This is something Jeremy could never do. But let's just say I'm going to size an inverse time circuit breaker. It's a squirrel cage motor. We'll say it's 50 horsepower, 460 volts, 3-phase, and we're going to do a design B motor. Okay, make it quick. All right. And the same principle is going to fall here that I'm looking at this calculation. So let's say you go over now, and I'm going to start you through a code loop of how to do all this. So in order to get all this started, I need to go over and look at 240.4G.
Sounds like Weedman's pretty impressed on this.
Yeah, that's why he's putting this kind of stuff, because he doesn't want anybody to look like they know what they're talking about. Only he's the one that knows anything.
Yeah.
But if I go look at Article 240, that deals with overcurrent protection devices. I go look at 240.4G. Now, this is a good point here, because when you go look at Article 240 and
He's making the question, Weedman, you're not.
Yeah, I'm doing something right off the top of my head here. So if I look at 240.4G, what does that deal with? Now, this is a good point, because when you look at that, it's going to talk about specific conductor applications. So let me explain what this means, okay? If I look at 240.4B, for instance, and you're looking at protected devices rated 800 amps or less, and I want to explain what it's going to say there. It's going to tell you that the next higher standard overcurrent device rating, or it has in parentheses, above the ampacity of the conductors being protected, shall be permitted to be used. Okay, I'm just going to stop there, because that's a general requirement. And if I do just a general calculation, basically this is going to deal with where you're doing continuous and non-continuous loads. Okay, so if say I calculate something and say I'll use this as an example, and I come up with 58 amps. Okay, now and y'all can just follow along this later and go back and forth, stop it so you can follow along with this. If I go look at table 310.16, I pick up the 75-degree column, come down, the next size above at 58 amps is 65 amps. Okay.
Yeah.
That'll
number
be
6.
Number 6 conductor. Now, if I go over and look at 240.6A, which is now going to take you to table 240.6A, and I go down and I look at the next size above that overcurrent protection device, it's a 60 amp. But yet I can protect based on the load, or I can protect what? The conductor. So
True.
Now if the conductor's at 65 amps, I can look at that table again, 240.6A, and it tells me next size above that's a 70 amp. So I could actually use a 60 or 70 amp on that overcurrent device. Okay.
True.
Now, the reason
and Weedman says you have to have 100 amp conductors and 100 amp overcurrent, and I don't know why. It's just
he
weird.
doesn't know what he's talking about.
True.
He's just showing his idiocy all the time. Now,
I agree.
what I like to explain at this point, when I'm dealing with specific conductor applications, you're getting into higher percentages. Now, when you look at that table, you're going to see on that left-hand side, you're going to see your motor control circuit conductors, and then you come across for the application of your article and section, it's going to tell you to look at Article 430, and it's going to say parts 2, 3, 4, 5, 6, and 7. Okay, so you got all these parts that you need to look at this point. Now, since I've started right there, now what do I want to do next? That is the question. Now, when you go over and I'll tell you this, since we're doing a motor, you would start at part 1 there. Just go over and look at Article 430 and pick up 430.6A1, and it said basically this is what you're going to read. If you're sizing your overcurrent device or your conductors, you're going to use the table values. If you're sizing your overall protection, you're going to use the nameplate, and that'll be in 430.6A2. So now I have established I have to use the table values. So since it's a three-phase 460 volt motor, I'm going to go over and look at table 430.250. I'm going to come down. I'm going to pick up the 460 volt, come down 50 horsepower. It's going to tell you it's good for 65 amps. All right.
Sure.
Now it's at this point when I was out teaching, I would give them code loops they write in their book, and I'd tell them right there at that table, if you're sizing conductors, they would write that down. I'd say, go look at 430.22 is for a single motor, 430.24 is for multiple motors. When you're sizing your overcurrent device for a single motor, we're looking at 430.52C, and if you're going to do one or more motors, you need to look at 430.62. We're doing one motor, so we're going to look at 430.52C1. And right there, it says to start, you cannot exceed the value calculated. So that's where I establish a minimum requirement at this point as a starting point. Okay. Now, you can go below that if you want, if it'll allow the motor to start, but this is a minimum starting point for you. All right. Now, if you go over and you look at that table for a squirrel cage motor, it's going to tell you to take that at what? 250%. Right? So now what I'm going to do is I'm going to take the 65 amps times 250%. That's going to give me 162.5 amps. Okay. Says I can't exceed the calculated value. So now I go back to table 240.68. The next size below that's 150 amp.
Right.
Okay. Now, without me doing anything else, I said you can go up to the next standard size without doing anything, and you're going to look just right below that at 430.52 CA1. And if it says it won't allow the motor to start due to inrush current, for instance, then you can go up to the next standard size. So the next standard size for table 240.6A is going to be 175 amp. Okay. So we've established 150 and 175 amp at this point.
It's a minimum starting point, Weed Man. I don't know why you're having trouble understanding this.
And listen to this. Maybe you can explain this, Jeremy. Now, the next one I'm going to do is the maximum size. Okay. Now, I'm doing an inverse time circuit breaker. I didn't exceed 100 amps for my motor, so I'm going to be able to take this at 400%. But one thing I want to point out there, everybody, if you go look at table 430.52C1, oh, this is interesting because you know what the heading says there, everybody? Maximum rating or setting. Well, this is the maximum rating or setting for your starting point at 250%. You will not exceed what this percentage is here. This is the maximum percentage you can exceed in this table. Okay.
Yeah.
That's we started with 65 or 250%. And I started with a minimum size. Then I went to next size. Now I'm going to maximum, and I'm looking at 430.52 C1B, and it tells me I can take it at 400%. So 65 amps at 400%, it's going to give you 260 amps. You can exceed that value. It says right there, I'll read it for you. It says the rating of an inverse time circuit breaker shall be permitted to be increased, but in no case exceed 400%. So in no case it can exceed. So that means I have to do what?
Drop down. Yeah.
So if I come up with 260 amps, I go over and look at table 240.6A. The next size below that's 250 amps. But can I go below that 250 amps, maybe to a 200 amp, Jeremy? Sure I can. Same thing. You're setting up and you're getting a basis in order to do your motor calculation. And that pretty much, everybody that's watching this, that's how you go about doing calculations. Now I'm going to give you a rule of thumb, and bless his heart, Ryan tried to prove me wrong on this, and he ended up confirming. He goes, but what he was doing the motor calculation. He goes, but why wouldn't you just go up? I mean, that goes, show, you know, they try to tear you apart, and then they realize they're looking even more ignorant by making these statements and everything, and they actually agree with what you said. And statement I made, I was on NEC Live. They asked me to come on. I was there 2 weeks. First week I did conductors. Next week I did overcurrent devices. And I made a statement. I said, if you calculate anything at 125% or less, you go up to the next standard size overcurrent device. Anything above that percentage, you're going to drop down. And I'll never forget Derek. He goes, I've never heard that before. And I said, I'll prove it to you. And after I prove, he goes, that makes it much easier to understand. And I said, sure. Yeah. And I told him, I said, the only 2 places in the code that doesn't hold true is when.
Oh, let me guess. It's transformers and phase converters.
That's right. You look over at 455.7B and then transformers, it gives you the option to go up or down.
True.
So
no, that's cool, man. It's a really popular topic. It looks like we crossed the 120 comment line on your topic of the week this week. So congratulations.
Well, one of the things it's one thing for somebody to come on and just, and they just start heckling you. Basically, he's a heckler is what he is.
Yeah.
But when you go in and you start showing all this and tying it in and showing exactly what the code says, and I can tell you, bless your heart, Jeremy, but people are sitting here and they're listening to what we're showing them in the sections and explaining exactly. They're agreeing, Jeremy. They're not agreeing with you. And
we're showing it and you're saying we're not showing it. So I don't know. I don't get it.
Well, so then I'm not going to spend much time on this because Jeremy took up a lot, but you're going to look at 430.24, and this is where you have several motors and other loads, and they're going to look at exception 4, and it's the same thing that we're doing on everything else, but the thing they're going to mention here is where you got a group of 1 or more motors and they're rated as design B or CE motors. Okay.
Right.
So when you get over and you look at that, there's some rules here, but you'll see we have we put a tip in here for you at the top of this illustration, and we give you 6 steps on designing here, and we take you to 430.22, the conductors, the overcurrent device, the controllers, the overloads. You just follow through this, and this will get you through what you need to do. But basically, it's the same thing as designing, a regular.
Is that how they draw the prints?
Yeah.
Oh, I can't believe the ignorance of weed, man. He just makes himself look so ridiculous.
Well, I mean, he can act however he wants to. I've just sort of whatever,
Yeah.
Now, what they did do here, they did do a little revision here, and this is also including the BE and CA motors, and this is where you're doing an instantaneous trip breaker, and you'll see it's the same type of calculation. We got 50 horsepower at 65 amps. The maximum size was 1100%. So your maximum setting for this using an instantaneous trip circuit breaker would be 750 amps. Same type of calculation. So we did take the time to draw these out for you where it's easier for you to understand and know exactly what they did. Now, this is the last one, I think. This is going to be 430.208A through E. And when you get over here and look at this illustration, the thing I would point out here, this is going to be dealing with the disconnecting means. And this is where you have motor circuits over 1,000 volts or 1,500 volts DC. And when you look over at this, they're going to tell you when you put that disconnecting means in place, you're still going to have to comply with 430.102, and you're also going to have to apply with 110.25 that it has to be lockable. Okay.
Right.
So those are a few things that you'll look at. And the other thing that I would point out that's probably important in that also is the current rating, because they're going to tell you those disconnecting means for those motor circuits that they're required to have a current rating that's not less than what? The overload trip current setting.
True.
Okay. And those are just a couple of things that they added in here, but the main part behind this is they're going to refer you back to all the other sections that deal with disconnecting means. The two most important are 430, 102, and 110.25, but also they also talk about other spots you would look at. You got 103, 104, 105. I think it's 107 and 112 and 13, if I'm not mistaken. But you would go over and look at those. So,
Sure.
but what we did, we put you 4 notes in here, different things you need to look at. The 4 main ones, 5 and 6 are probably important too, but the main 4 ones are the top 4 we have here on the side that you need to address.
Nice.
Okay.
I like that.
So
Well, I think
that's
it's
it.
really funny that Weedman says that we don't want different opinions on our podcast. But the thing is that I could have my opinion, James could have his own opinion. We're just interpreting what the code says, and for some reason you're just you want to be like the loudest voice in the room and you want to be on the show. So I don't
Well,
get it, but
what I
that's
don't
just me.
understand is why don't they do their own show?
Yeah.
If you're so smart on the code, do your own show. Let's see if people agree with you.
Yeah.
That's when you start knowing if what you're saying resonates. And I'll tell you, Jeremy, what have you said? Nobody watches this show. Then maybe you could explain to me how it was our show that was transcribed before the Standards Council.
True. That happened.
Those are just facts, people. That's
Yeah.
not something
True.
to make it. And I'll tell you why it happened.
And they sided with us how we thought it should be voted on.
That's right. And that is a great point, is we went through and we broke down the code and everything. And I think what's happening is you got other code making panel members that watch this. And I think they're listening to what's being said. And I think they're going into these meetings, and this is where the argument's coming in. And these other guys that are trying to push this can't hold their ground and explain what they're wanting to do, because we're actually showing the code and the intent. And we, like we've said over and over and over, use the code as a whole. And when you start learning to do that, things start making more sense for you.
100%. Amen, brother. Let's move on to the tool. We're running out of time here.
We're good.
It's time for Tool Review of the Week. Sponsored by the Christians Only Tool Review and Nipex Tradesman.
All right, so I decided to have a little friendly competition between Milwaukee and DeWalt with these whole hogs. And this is the one that a bunch of my buddies use. They say it's really good, and you got to get the 9 amp hour. I think they're like a heavy duty 18-volt battery that they put on there, and they say they work great. They say that, a lot of guys, the reason I'm using this, because a lot of guys use these for tuggers too. There's actually a setup where it's just a whole tugger setup, and you just clip this drill in, and then it runs a tugger and it pulls your wire too. So we're going to have a little friendly competition with these, see how versatile they are, and we're going to try to see which one all the electrician buddies of mine think is the best. So far, everyone says the Milwaukee is the best. They say it's like the most versatile. They say it has the most power, and they say that they've never seen one get smoked. But we'll see, because I'm going to try to put it to a test with DeWalt too. So that's kind of what I wanted to do this series, is kind of go with these little whole hog things, and they're very versatile. So you could use them for residential with the auger bit, drilling out wood studs, or you could just clip this baby right onto your tugger and have this thing run your tugger. So that's something I hadn't seen before. I have seen the corded ones that they've used. I've never seen them use a cordless one before. So we're gonna see how it works. It might not even work at all. We'll see. But most of my buddies are pulling some serious wire, and they'll put it to the test. And if they can smoke it, I can guarantee they'll smoke it. So we'll see, but like I say, that's the whole reason why I do these tool reviews is to kind of get these products out there. This one right now so far has the lead as far as the best whole hog out there. But we'll see. I'm gonna try to reach out and get some more information on the DeWalt one for next week, and then we'll see who actually wins. I'm really putting money on a DeWalt, but right now it's falling behind. So we'll see. Like I say, the Milwaukee's actually getting a lot better in their battery technology and stuff. So that's I think where they're kind of starting to win this war a little bit. But DeWalt for me has always had the best batteries out there. So
All right.
we'll see next week, but I really recommend that as far as for just a versatile, powerful whole hog that you want to use multi-purpose. So they come in handy. Like I say, you want to do residential, you go run one of them babies with the auger bit, or you slap it on your tugger and pull a commercial run. So we'll see next week who gets the crown. But what do we have? Man vs. Machine?
Yep, I redid this one.
I
I'm
noticed.
actually going to be upgrading a lot of stuff here.
Okay.
Hopefully you have it done next week. I was going to get it all done this week, but Dad had some problems, so I had to deal with it.
Yeah.
So here we go.
I'm just glad he's all right.
For years, man tried to create artificial intelligence. On this segment, we find out, is AI smarter than King James?
I like that. That's cool. That's
Yeah,
nice. I
I
like it.
try to do it a little bit different. Just there's quite a few things I'm actually going to redo. All right,
Yeah,
let's see.
this one is gonna be a little tricky.
Metal thickness. God, this will be a complete guess.
Oh man.
All right. I don't think it'd be 0.050. I'm between B and C, and I'm unsure. I know that this particular one, it's a multi-outlet assembly, so it's going to be, I think that is what, Article 380, I think it is.
Yeah, 380 something.
Yeah, 380, I think is what it is. And God dang, I do not really know metal thickness.
You know how I'm trying to pull you too.
You're an asshole doing this type of question. Damn.
Got him. No, I'm just kidding.
This is a guess. It's I would say probably point. It's one of those fours. I got a feeling. This is complete guess. I really have no freaking idea. I don't think it's one of the tour thicknesses ones down there, and I definitely don't think it's 0.03 because I probably went 0.030 inches if it the voltage was less than 300.
Right.
This may be one I'm going to miss. I'm going to flip this. I'm going B or C.
Yeah.
Give me a second to get my coin out. Come here, coin. All right.
Get that Hillary Clinton flip in there.
Let's see. Heads for B. C. I got heads, so I guess I'll go with B.
All right.
I got it wrong. That's fine.
We'll see. Let's see what ChatGPT has to say and see if
All right.
it agrees with you.
This is a total freaking guess. That's a bullshit question.
It's
Okay,
in there. It's in the book, man. I
let's
use the
see.
code as a whole.
Let's see what ChatGPT says. It said B2. It even gave the section. Wow, it gave you the section. It's never done that before. So it says
All right.
380.12.3. Let me go over here.
380.12. Oh, all right.
Let's see. Give me a second.
You know that ChatGPT is watching the show right now. That's what it is.
So I'm going over here. 380. Okay,
So it was a really hard question to write because there's so many different items in there.
Yep, it's 0.040 inches.
You got it. Oh man, I thought I was gonna get you a 0.042 because you'd be like,
That is correct.
Oh, that was so fun.
You even had the correct NEC section. King James had the right answer, but wasn't sure of the correct NEC section.
Yeah, it's getting better. Definitely getting better.
All right, let's see what it says. I have to say, I've enjoyed your Code Question of the Week series. They strike a nice balance between being straightforward and making people dig into the code book instead of relying on memory. Those are the kind of questions that spark. So thank you. I appreciate it. And credit where it's due. King James clearly knew the technical requirement. No, I didn't guess. I second guessed it. I didn't tell you that.
Yeah. That was funny. It's hard for me to write those that I think's gonna stump you.
So I'll tell it. Place in the master chat GPT.
There you go. All right.
That is awesome. Yep. Master log numbers 156.
All right.
We've done 156 of these with him.
Wow. That's crazy.
That's how many we've had in the master log. Everything that we've asked it has kept a reference of everything that we've done. That's unbelievable.
That's awesome. And we're making it better. It's got to get better. It probably practices all week just for Thursday night. Practice all week for Thursday night.
That is freaking unbelievable. All right, ready for Willie Quiz?
Let's roll. So I doubt Daniel's gonna show up this week because like his dad's in town, so he's been spending time with his dad. So it's gonna just be you against King James this week, but we'll still have some fun doing it. So this is about the World Cup, and I really had a good time recording an episode on the Willie Jackerson experiment. So check it out. And which nation has won the most FIFA Men's World Cup titles? Is it A, Germany? Is it B, Italy? Is it C, Argentina? Is it D, Brazil? Or is it E, Spain? Good luck, everyone.
Well, since nobody's going to be answering, I won't even play the Jeopardy.
Yeah, that's fine.
Yes. Golly. I think, isn't it Brazil? it's Argentina or Brazil, but I don't think it's Argentina. I think they're one shy of Brazil. I'll go Brazil.
You are correct. Brazil has 5.
Yeah, I thought I heard that on one of the when it was first starting, and they were talking about the World Cup, and I was watching. I thought that's what they said because they were talking about who had the most wins.
All right, so the 2026 FIFA World Cup became the first tournament to feature how many national teams? Is it A 32? Is it B 40? Is it C 48? Is it D 54? Or is it E 64?
Actually, know this one, 48.
All right. You are correct. 48 is the correct answer.
It's one of the easier questions I've had in a long time. I actually heard talking about that one.
I knew that Daniel wasn't going to be in, so I didn't have a chance to call him and tell him what the answers are going to be. All right. So question number 3. What player holds the all-time record for the most FIFA Men's World Cup goals? Is it A, Miroslav Klose? Is it B, Pele? Is it C, Lionel Messi? Is it D, Ronaldo Naciano? Or is it E, Kylian Mbappe? Good luck, everyone.
Well,
or good luck, King James.
Lionel Messi's one behind him. I heard him talking about this, and I didn't know this guy's name, but I heard him talking on the podcast, and it's at Mbappe, or however they say it.
Mbappe has 22. Messi has 20. I think he has 21. Mbappe has 22, and then Mbappe got the golden boot.
And wasn't it if he because I remember talking if Messi scored the last game, he would have tied him.
Yeah,
the World Cup. Yeah, that's how I knew that.
Yep. All right, which nation became the first to win the FIFA Men's World Cup in 3 different continents? Is it A, Germany? Is it B, Brazil? Is it C, Argentina? Is it D, Italy? Or is it E, Netherlands?
I have no freaking idea. I'll just go with the team that's won the most, Brazil. I don't know.
Yeah, well, you'd be correct. It's Brazil.
So, I had no clue. I just went with who won the most.
Yeah. Which of the following is a new record established by the 2026 FIFA World Cup format? A, most goals in a tournament. B, most participating teams in Men's World Cup. C, most host cities in a World Cup. Both B and C, or E, none of the above?
I think they had the most participating teams. I knew for sure. And then, of course, we had a whole bunch of host cities. So I'll go B and C.
I buttered you up for next week. So you got 5 for 5, and just wait. I'm gonna make sure it's gonna be harder next week. So
those were actually easier questions.
They were, yeah. I think for me, I kind of just wanted more to, showcase the, the World Cup and everything. And so, as tradition has it, I will get the pickle shot for Adam. Adam, we love you, Team SOS, bro. Go check out Team SOS. Pickle shot down.
Well, I'm just going to say this right now. That's a win. I don't care what anybody says. I got
That's a win
this week.
You better cherish it, because I'm going to be able to call Daniel next week and be like, all right, show up at 8 o'clock and here's all the answers, and you know what I mean? So I'll be able to rig it next week. I couldn't rig it this week. So
yeah. All right. Let's do the last one. Wall of Shame. Finish her.
Yep, let's do it.
Shame. 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 Shame.
This one was funny when I saw it. I was like, "Oh man, King James is gonna love this one." Little
that
Cat
hanging there?
6 parallel.
That
I got little data cable freaking paralleled onto there. I guess it worked like that.
it's not mounted. It looks like it's just hanging.
Well, no, what it is so and I this is posted by Nick and what he's doing is he's demoing. And
Oh,
so this is
okay.
what they found that they did previously.
I see. Okay.
So he's pulling it out of the wall, and then he's like, "Look what I found!" And I thought that was hilarious because we're finding some of the same weird stuff in the schools we're doing.
Okay. Yeah, because I
So
was sitting there thinking, why is it just that it's just hanging it there? I was like, what the hell?
no, he's just showing that he pulled it out, and that's the cable that it has going
Okay.
to it,
I got
and
it.
it's just
Yeah.
a parallel Cat 6
Yeah.
parallel to it's 222 gauges to make a 16 or whatever.
Mhm.
I guess it worked. I don't
Yeah.
know.
Parallel run, baby.
I guarantee they didn't consult the manufacturer's instructions on that one.
No, they didn't.
So, means a lot. Thanks so much. Appreciate you putting it together. I always have so much fun every week, and might have to not do a show next week. We'll see. My schedule's looking pretty rough. I might be stuck like way down south next Thursday, but we'll see. Crossing my fingers. I'll know on Wednesday. I'll let you know when I put the show together. Hopefully, crossing my fingers, we'll have a show next week. But
Okay.
you know,
No worries.
it is
All
what it
right.
is. But last show of July, I think.
Yeah.
What next Thursday is what, the 30th?
Yeah. And then we're 1 month out to football season.
Yeah, we're getting there. Then we'll do Monday morning coach.
Oh,
I'll send you a
football
link.
season?
I'll send you a link. I got a fantasy league going, so we'll
I might get in a fantasy league. I hadn't done that yet. So everybody,
yeah.
I had my friends, why don't you get it? You know so much about football. I'm like, I don't know. I just got so much other crap going on. So
Yeah, it'd be fun if we get it going. We were gonna do a fantasy league where you had to pick like X amount of players of your team, like if you pick the Broncos and stuff. That'd be pretty fun too.
yeah.
We'll figure out something. We'll get something together. We might even just do it for the show. Just do like I'll do a Bronco fantasy and you do a Cowboy fantasy or whatever, and we'll draft who we want or
We can
whatever.
just throw it in here if we want to.
Yeah, or whatever. Throw it in here too.
Yeah,
But
we just say the high voltage football.
yeah,
Just come in, just let everybody come in and hang out, So
we'll get it together. Maybe we'll have something like where you have to take quarterback, running back, or 2 running backs, 2 wide receivers, maybe a defensive player or something.
Yeah, we'll
Like
figure it
make
out.
it fair, whatever. We'll figure something out. We'll get it together.
All right. Let's
Yeah.
wrap her up. I'm done. I want to go eat. I'm hungry.
Well, like I always say, everyone, make every day an easy day.
Amen. Everybody have a good weekend, and we will see y'all maybe next Thursday.
Maybe. Deuces.